A very good day to Dr. Azwan. We are from Group 1, Sections 3 and 4. Today, we are going to present about the teaching video of the experiment of conductions, conversions, and radiations.
Good morning, Dr. Azwan. My name is Tamara Hong and my thermometry is 220 and 137.
My name is Elisha Laijiachi with my matrix number is AD220157.
My name is Ong Si with my matrix number is AD220136.
My name is Janet Jawuni and my matrix number is AD220130.
Let's start by understanding the concept of conductions. The definition of conductions is the transfer of energies from the more energetic particles of a substance to the adjacent less energetic ones as a result of interactions between the particles. Heat transfer to a solid material or between objects in direct contact caused by the vibrations and collisions of particles. To some examples, when we hit the end of the metal rod, the heat transfer through the particles due to the vibrations and collisions. Next, the equations of the rate of heat transfer of the conductions is negative K times A times differences temperatures divided by the thickness of the materials. The K represented the thermal conductivity. When the thermal conductivity is higher, means that the material is a good conductor. So A represents the area of the material.
Now I will talk about the procedure of our conduction experiment.
Firstly, three equidistant points, point A, B, and C, were marked on the metal strip. Then, the metal strip was placed on the laboratory hot plate. The initial temperature at each marked point was measured and recorded. Next, the hot plate was turned on and the stopwatch was started. The temperature at each point was recorded every 30 seconds for 5 minutes.
Here is our result table. We got time, the temperature at point A, point B, and point C. In this experiment, the total time we used is only 300 seconds only. And from this result table, we can see that our temperature is totally increasing. So right now, we will further discuss in the next stage. And here is our graph of temperature versus time at different positions, which is point A, point B, and point C on the metal plate by using the laboratory hot plate. First of this graph, we can see that the point A, which is the blue line, the point B is the red line, and the orange color one is the point C. We see that the blue line, which is point A, it achieves the highest temperature. This is because of the point A is the closest to the laboratory hot plate, which is the heat source. Also, it shows that the temperature along with the metal plate will be less effectiveness if the position is far from the heat source. And right now, I will pass to my group member to present the conclusion part.
And now I will present for the conclusion of conduction experiment. The experiment showcases a direct transfer of heat through a solid material, where temperature gradients cause the energy flows from higher temperature region to lower temperature ones. The plotted graph just now at different points along a metal strip confirmed the steady state heat transfer behavior and highlighted the role of thermal conductivity in determining the rate of energy transfer. That's all from our conduction experiment.
Furthermore, let us move to the convections. The definitions of the convections is energy transfers between a solid surface and the adjacent fluid, which is liquid or gas that is in motion, and it involves the combined effects of conduction and fluid motions. This phenomenon can be observed in our daily life, which is boiling water. When a fluid is heated, it becomes less dense and dries. Meanwhile, when it's cooler, denser fluid sinks and it will create a circulating current. The next is the equations of the rate of heat transfer. Q dot equals to H times AS bracket Ts minus T infinity bracket. The H is the convection heat transfer coefficient, and the AS presented the surface area, and Ts is the surface temperature, and finally the T infinity is the temperature of fluids separating far from the surface, which is the temperature surrounding.
The first step to start this experiment was to fill the beaker with 300 ml of water. The beaker was then placed on a hot plate. A drop of ink was added, the hot plate was turned on, and the stopwatch was started at the same time. The hot plate temperature and water temperature were monitored, so do the time taken for the water to reach equilibrium.
Here is our result table. We got time, the temperature of the water, and the temperature of the laboratory hot plate. The total we used in this experiment is only 510 seconds only. Alright. The purpose of this experiment is to let the temperature of the water and the temperature of the laboratory hot plate to achieve the same temperature. It is 49 Celsius. We call it as equilibrium. And now we will discuss this page for the further information. Here is our graph of temperature versus time. The blue line is showing the temperature of the water. The red line is showing the temperature of the laboratory hot plate. Based on this graph, you can see that the temperature of the laboratory hot plate is increased more rapidly than the temperature of the water. This is because of the laboratory hot plate is directly hit by the heat source, while the temperature of the water it increased more slowly or more fast. This is because it is due to the process of the heat transfer. We call it convection. Also, the heat is distributed along with the water volume. And now we will go to conclusion part.
The experiment illustrated the movement of fluid driven by the temperature differences, creating the convection currents. The data shows a gradually increase in water temperature, which closely follow the heating plate's temperature profile. This validated the concept that heat transfer through convection is a combination of conduction and fluid motion, with heat transfer rates influenced by the fluid properties and also the temperature profile. This is all from our convection experiment.
Finally, we have radiations. The radiation means that the energy emitted by metals depending on its temperature or surface properties in the form of the electromagnetic waves or protons as a result of the charges in the electronic configurations of the atoms or molecules. Unlike convection and conduction, radiation does not require the interpreting medium. To cite examples of radiations, the sun transfers the heat to the earth. Next is the equations. Q dot equals to E times sigma times AS bracket TS power of 4 minus T sub power of 4 brackets. The E is representing the emissivity of the bacteria, and the sigma is the sigma boson constant, which is 5.67 times 10 power of negative 8. And the AS is the surface area, TS is the surface temperature, and T sub is the temperature of surroundings. That's all from me.
Now I'll explain the procedures conducting our radiation experiment.
Firstly, the laboratory oven was preheated to 100 degrees Celsius. The mass of each sample was measured using a weighing machine. The samples were put inside the laboratory oven and heated for at least 15 minutes to ensure uniform heating. The laboratory oven was then turned off. The surface temperature of heated samples were measured at regular intervals until equilibrium with ambient laboratory temperature.
Okay, here is our result table. We got time and temperature. We got two samples there, which is sample B and sample S. So therefore, we have temperature of sample B and temperature of sample S. In this experiment, the total time we use is only 3000 seconds only. Okay, the purpose of the object is to let the sample B and the sample X let their temperature achieve the same temperature. It's same with the ambient condition, which is 25 Celsius after being heat and exposed to the ambient condition. And right now we will move to next page to further discuss. So here is our graph, the temperature versus time. There are two lines there. The blue line will represent the sample B, the temperature of the sample B. The red line will show the temperature of the sample X. Based on this graph, we can see that the temperature of the sample B and the temperature of the sample X show a curve. It's an exponential curve. It decreases in temperature with the time. If we do the comparison there, we can say that the blue line, the temperature of the sample B, have a slow rate than the temperature of the sample X. This is because the higher temperature are there, but over there they achieve the same temperature, which is 25 Celsius. And right now we will move to conclusion part.
The result of the radiation experiment emphasized the heat transfer through electromagnetic waves. The cooling rate of surface with varying emissivities highlighted the significance of material properties such as surface color and also the texture. The Stephan-Boltzmann law was effectively applied to quantify the radiative heat transfer, showing a strong dependence on the power of the absolute temperature. That's all from the experiment of radiation.
Finally, all three of our experiments are conducted successfully. We take advantages using the ceramic lab in Jufu block. We express our gratitude to Mr. Fazran, who is the head of laboratory, upon all the helps given to us. That is all of our presentation today. Thank you.